Morning, we are discussing about the coagulation or precipitation or fluctuation. Fluctuation we are discussing. What is the meaning of coagulation? Conversion of solid particle into precipitates by doing something or by using some different methods is calling as a coagulation or precipitation. Under that already I told boiling. Now I will tell one more process for coagulation. It is nothing but direct electroforces. Direct electroforces. What is this direct electroforces? First of all, we should come to know electroforces is one of the method to identify the charge on the solid particles. But then you observe now, you taken U-shaped tube you taken, but we kept the electrodes directly in the soil or in the water. In the water. If you kept directly electrodes in the soil, what happening? I will tell you, see carefully. Direct electroforces means if you keep electrodes directly in soil, what happening? For example, you take an anode. So anode means which rod? Positively charged rod. Then what happening? If soul is the negative, then what happening? And negatively charged colloidal particles moving towards anode. There what happening? Oxidation will be going on. Are you getting or no? Oxidation will be going on. What is the meaning of oxidation? Losing of electrons. Means the negative charge will be losing. Then they are becoming a neutral colloidal particle. They are aggregate together, becoming like a precipitate particle. Are you getting or no? No. For example, you taken at cathode. If suppose soul is means cathode means which rod? Negatively charged rod. Which particle is moving? If soul is a positively charged colloidal particles, they are moving. Very clear. At anode always oxidation will be going on, and at cathode always reduction will be going on. Reduction is what? The positively charged particle will absorb electron, becoming neutralized. Means there always reduction will be going on. Under that reduction, what happening? The colloidal particles are becoming chargeless. They aggregate together, becoming like a precipitate, like that. Anyway, sols are converting into precipitate just by sending current directly into the soul particles. And I want to tell you one more thing. It is nothing but complete dialysis. Complete dialysis. Okay, what is the meaning of dialysis generally? Okay, after preparation of the soul, in the soul, if any excess of electrolyte will be there, that should be removed by using attachment paper. But now what you are doing? Complete dialysis you are doing. What is the meaning of complete dialysis? What is the meaning? Yes, sir. Completely means we are removing or we are completely removing the electrolyte. Completely we are removing the electrolyte. What we added in the preparation of soul. Yes or no? While preparing soul, definitely we are adding some electrolyte from outside to become stabilized. That added electrolyte is completely removed. Then what happening? What happening? They are becoming chargeless. They are becoming chargeless means definitely what happening? Aggregate together becoming like a precipitate. See, for example, you have a soul particle. Okay, those soul particle, for example, AgI is there. Now what you did? You added Ki. You know very well I particle is undergoing sticking here. Then every colloidal particle is becoming like a negatively charged particle. Now what you are doing now? The added electrolyte is completely removed. Then what happening? There is no charged particle on the colloidal particle. There is no charges. They are becoming aggregation. Aggregation means becoming a precipitate. That's also calling as complete dialysis. Now I will give you one more technique. Is important one. It is nothing but mixing of two oppositely charged souls. Two oppositely charged souls. Sometimes we asked this one in completed examination. How we are getting coagulation by mixing two oppositely charged soils means, for example, I am taking a positively charged soil. I am taking. Can you give one example for the positively charged soil? Ferric hydroxide soil. FeOH taken thrice. On this, which particle is coming among? Fe plus 3. If you can take a negatively charged soil, you can take. Negatively charged soil means generally sulfide. You can take silver iodide also, but compulsory between these two charged particles, chemical reaction has to be takes place. I am taking arsenic sulfide. I am taking As2S3, and on this S minus 2 is there. Okay, we have to mix the two oppositely charged soils in a required proportion. Then what happening, anybody? Yes, whatever positive particle here that will be involving in the chemical reaction with S minus 2. That only I am writing here. See, Fe plus 3 is involving in the reaction with S minus 2. What happens? Neutralized. How? What is the valency of this particle? 3. What is the valency of this particle? 2. Yes or no? Then do cross multiplication. Then what is coming? Fe2S3. So both the collider particle charges are becoming like a neutral particle. Then what happening? The collider particles are becoming chargeless. Then what happening? There is no repulsion between them. They aggregate together, then becoming like a huge particle. That is only we are calling as a precipitates. All of you getting or no? Yes. These are techniques to get the coagulation. And very important and nice concept is coming. Most of the competitive examination asking this question. What is that one? Is listen carefully among. By adding electrolyte. By adding electrolyte also coagulation will be possible. How? And nice concept is there. Okay, first of all we have to take the soul particle. We have to take soul means nothing but colloid. For example, I am taking silver iodide colloid. I am taking. Okay, on each silver iodide what will be there? I minus will be there. Yes or no? That's why the soul is calling as a negatively charged soul. We know very well this one. Okay, now what I should do? I have to precipitate them. I have to precipitate them means I have to remove the charge from the colloidal particle. For that, what I am doing? Electrolyte I am adding from outside. For example, I am adding potassium iodide. I am adding. Okay, how potassium iodide will be decomposing? K plus ion. Sufficient stabilized, more dangerous. What it will do? Whatever this K plus particle will be there, that will attract I minus from the surface of the colloidal particle. Then what happening? The K plus will combine with I minus is becoming like Ki. After removing the charge from the colloidal particle, all the colloidal particles are becoming chargeless. After becoming chargeless, what happening? They haven't any repulsion between them. They haven't repulsion means they are aggregate together. Aggregate together means it's becoming like a precipitate. Did you got my point? Yes, sir. While preparing soil, we are adding. That's why we told starting only a little bit of electrolyte is enough to stabilize the soil for the preparation of the soil. If excess of electrolyte will be there, causes damage. That's only we are catching here. If you want to disturb them, compulsory we are adding some electrolyte from outside. From the adding electrolyte, the ion which is having opposite charge with colloidal particle will cause the coagulation. That's K plus particle only we are calling as coagulating ion. Coagulating ion, or also calling as a flocculation ion. Flocculation ion or flocculating ion. Are you getting it? What is the definition of the coagulating ion? The ion which is coming from the electrolyte, it should be having opposite charge with the colloidal particle, causes coagulation. So such ions only we are calling as coagulating ion or flocculating ions. Here one important point is coming. All of you understood? Here I minus is useless. K plus is only plays very effective role in this process. That's what it's calling as a coagulating ion. Now I am explaining power of coagulating ion. Power of coagulating ion. Power of coagulating ion. Very nice concept. He asked in so many competitive examination. For example, I am taking a negatively charged soul. I am taking. I want to coagulate it. What hand is required? You have negatively charged soul will be there. I want to coagulate it, means I want to precipitate it. What is required? Positively charged particle is required. For example, I am taking coagulating ions on different amount. For example, I am taking Na plus particle I am taking, and Mg plus 2 particle I am taking, and Al plus 3 particle is taking. Observe the concept faster. Final conclusion is helpful for the competitor. Every colloidal particle will carry unit negative charge. What is the meaning of this one? Every colloidal particle carries -1 charge, for example. Okay, now you have that one. To that you added Na plus particle. Can coagulate how many colloidal particles? Yes. Why? Because each sodium carries +1, each colloidal particle carries -1. Neutralize together. Every sodium can coagulate only one colloidal particle. That's what I am writing here. One colloidal particle is undergoing settle down. No, we are taking one magnesium can coagulate. Very good. 2 colloidal particles. If you can use aluminum, it has a +3. +3 means neutralize 3 colloidal particles, because every colloidal particle carries -1 charge. That's why 3 colloidal particles will be undergoing precipitation. Can you tell the relation between its charge and the coagulation power? Yes, sir. One means what? Valence of the sodium. 2 means what? Valence of magnesium. 3 means what? Valence of aluminum. That's why I am telling one point here. Power of coagulating ion is directly proportional to its valency. Also we can tell in another way also. Anybody? Yes, very good. Magnitude of charge. Magnitude of charge on it. So this concept only we are calling with one special rule for 2 marks. Hardy's School's rule. Did you got my point? What is the Hardy's School's rule? In case of coagulation, to check or to identify the power of coagulating ion is directly proportional to its valency or magnitude of the charge on this one. Yes, more valency, more coagulation power. Yes or no? Otherwise, more charge, more coagulation power. That's why power of the coagulating ion is directly proportional to its valency or magnitude of the charge. That's what we are calling as Hardy's School's rule. Okay, he will answer the question. You have a negatively charged soul. What is the strength or what is the power of the coagulating ion order among these 3? Yes, very good. Al plus is the best coagulating ion. Then Mg plus 2. Then Na plus. This is important. Can I give one more thing? This is the one of the point. I will give you one more thing. Positively charged soul we have on. Okay, every colloidal particle carries +1 charge. You have to imagine like this. Okay, to coagulate it, which ion is required? Negatively charged. Very good. Negatively charged particle means Cn minus ion. I am using as a coagulating ion. Can add SO4 2 minus. Any problem? And phosphate ion, PO4 3 minus. And ferrocyanide ion is coming from potassium ferrocyanide. FeCN taken 6 times whole power -4. Yes, anybody? It can coagulate only one colloidal particle. I know that is only one colloidal particle because only valency will be 1. It can coagulate 2 colloidal particles because -2 can coagulate 2 colloidal particles. Everyone carries +1. Then it can carry 3. It can coagulate 4 colloidal particles. What are they? As the valency of coagulating ion is increasing, its coagulation power is also increasing. Otherwise, magnitude of charge, don't consider plus or minus or value has to be considered. More 4. That's why more coagulation power. That's why what we can tell. FeCN taken 6 times whole power -4 is more than. Phosphate ion PO4 3 minus is more than. Sulfate ion is more than. Chloride ion. Competitive bits means nothing. It's only bits. The coagulation power is directly proportional to its valency or magnitude of the charge on the coagulating ion. Just you see carefully. And one more important concept is coming here. The power power of coagulating ion expressed in coagulating value, very important concept, observe very carefully, are also calling as a fluctuating value. Okay, means whatever power of the coagulation ion will be expressed in two ways. One is the coagulating value, or also calling as a fluctuating value. What is the meaning of this one? Very carefully, you have to observe here, say carefully. Power of the coagulating ion will express in coagulating value. For example, you have a soap. Just you observe very carefully. What is the definition of the coagulating value, or also calling as a fluctuating value? I will tell the definition, then I will explain the concept. The amount of electrolyte is directly coagulating ion. The amount of electrolyte in millimoles for a liter, is required to cause coagulation of given soul in 2 hours duration. What is the meaning of this one? Coagulating value or fluctuating value means that amount of electrolyte should be expressed in millimoles per liter is required to cause coagulation of the given soul in 2 hours. Means you have a one soul. For example, that one I am explaining here. Yes, you have a one soul, whether positive or negative, let it be, and you are adding electrolytes, will be different electrolytes you are adding, like X and Y and Z. From these 3 electrolytes, what is coming? Coagulating ion coming. It is also automatically involving in the reaction with colloidal particle and becoming neutralized and becoming precipitate. Okay, that's why. Now, its coagulating value of this X will be 2, this Y will be 4 and Z will be 6. What is the meaning of this one? Yes, very good amount. For a given soul, 2 millimoles of electrolyte means X is enough to coagulate the soul. For a given soul, for coagulation, Y is required how many moles? 4 millimoles. Okay, for Z, 6 millimoles of Z is required for coagulation of the given soul. That's why these are calling as coagulating values. My question, among X, Y and Z, what is the best coagulating ion for the given soul? X. Oh, yes, very good. Logically observed. Are you getting? Among X, Y and Z, what is the best coagulating ion for the given soul? Yes, fine. Yes, just 2 millimoles is enough for coagulation, which is walking action will be very high. But Y is required a little bit more, means the working efficiency will be less. 6 means still it will be very less. That's why what we can tell, power of coagulating ion is inversely proportional to or directly proportional to its coagulating value. Inversely proportional to its coagulating value, or also calling as a fluctuating value. Very, very important. So X is calling as best and Z is weak. Are you getting or no? All of you understood or no? Yes. So power of the coagulating ion is inversely proportional to its coagulation value. Coagulation value will be more, means more amount is required. More amount is required means its efficiency under coagulation will be less. Okay, one more point I will tell for advanced examination point of view. I want to tell, see, if you want to find out coagulating value for any soul, any coagulating ion is equals to number of millimoles of electrolytes by volume of soul plus volume of electrolyte. Volume of electrolyte should be taken in liters. It's a very, very important formula. So based on this, what is the coagulating value or fluctuating value formula? The number of moles of millimoles of the electrolyte by volume of soul plus you are adding electrolyte volume, but all volume should be taken in liters. Better safe side, you learn this formula may useful in some competitive examination. All of you getting up? Yes. See, another concept, protection of leophobic souls. What is the meaning and everything we will discuss. It's also very important concept. Just you see, first of all, I am explaining leophilic souls. Leophilic souls are basically stable or unstable? Yes, very good, Amma. They are basically stable. Why? Because, Amma? Yes, very good. Because between disposal phase and dispersion medium, we have strong force of attraction. That's why they always mix it with one another. No transfer coagulation. That's why they are stable. That's why in case of leophilic souls, to increase the stability, no need to do anything. But problem with which one? Yes. Why? Because means you see here, in case of leophobic souls, they are unstable. Why they are unstable or less stable? Yes, because between disposal phase and dispersion medium, we have less or no force of attraction. That's why they always, disposal phase particle want to separate from the dispersion medium, then they lose its sole behavior calling as coagulation. Now, already they want to separate from one another. Still what I am doing, I am adding a little bit electrolyte I am adding. Then what happened? Still they are becoming unstable. Why? Because adding electrolyte will provide coagulating ion. The coagulating ion will neutralize the colloidal particle. Then they are becoming like a precipitate. Okay. In case of leophobic souls, basically they are unstable. Between disposal phase and dispersion medium, already less force of attraction or no force of attraction will be there. Okay. Basically they don't want to mix with each other. Still, we are adding electrolyte. Again, what happening? The electrolyte will what happening? Neutralize colloidal particle. Then they are becoming like a precipitates. I don't want this process. I want to stop this process. What I should do? To this, this is whole which one? Leophilic soul. No, sorry, leophobic soul. No, leophobic soul. To that leophobic soul, I should add a little bit leophilic soul. Then they are becoming stable. It will avoid or it will stop this entire coagulation process. How it is? That is only we are calling as protection of leophobic soul. Nice concept. Observe carefully. Okay, basically leophobic souls are unstable because between disposal phase and dispersion medium, force of attraction will be less. That's why they always want to separate from one another. Okay, that can be speed up by adding electrolyte. Means after adding electrolyte, the separation will be going with the high speed. That's only calling as coagulation. No, I don't want this coagulation. To stop the coagulation, what we can add? Leophilic soul, little bit we should add to leophobic soul. After that you can add electrolyte, no coagulation. Why? Just you see, for example, you have in case of basically, I will write here see carefully. Basically, I am taking leophobic soul. I am taking leophobic soul is there. What will be there? Colloidal particle is there, and we have dispersion medium. Just you see carefully. Dispersion medium is there. Okay, between them there is no force of attraction. But after adding electrolyte, the colloidal particle is undergoing coagulation. I don't want. To stop the coagulation, what we are adding? Yes, we are adding a little bit leophilic soul we are adding. After adding leophilic soul, even though you are adding electrolyte, what happening? There is no precipitation. Why? That is only calling as protection of leophobic souls by adding leophilic souls. What happened? soul, what happening? Whatever leophilic souls will be there, they are undergoing sticking on the surface of the colloidal particle and they are forming one of the protective layer they are forming. Protective layer they are forming. After forming the protective layer, is there any interaction between colloidal particle and adding electrolyte? No. No, why? Because it's closed. That's fine. Is there any chance for coagulation? No. In this whole process, which is protecting? Leophilic souls is protecting. That's why they are calling as protective souls. Which are protected? Yes, leophobic souls are calling as protected souls, and these are calling as protective souls. Did you got my concept? Okay, once again you see, after adding leophilic souls to leophobic soul, what happening? Why coagulation is not happening means the added leophilic souls are undergoing sticking on the surface of the colloidal particle, and the leophobic they are forming like a layer. After that, they are avoiding the interaction between colloidal particle and adding electrolyte. Then there is no transfer coagulation. Then they are maintaining much stable. And one more thing also we can tell here. This is a leophilic soul. And the dispersion medium is there. Between leophilic and dispersion medium, what happening? Attraction force will be going on increasing. Why? Because? Why? Because? What is the nature of leophilic? Loving with the dispersion medium. One reason, it is avoiding the interaction between electrolyte and colloidal particle. And one more reason, it's increasing the force of attraction between colloidal particle and dispersion medium, what is already present in the leophobic source. Like that, they are still going with one another. This way they are becoming more stable. Just I will give you some example.